All right, welcome to another CyberSec Tuesday. Uh, just a shout out to ArcLight 6 Consulting, one of our sponsors. They are a cybersecurity sponsor of ours. And for more information, you can check them out at arclight6.com. Tonight we have Barry Sploit going to be doing a talk on tracking lateral movement. So, Barry, feel free to take it away.
Thanks, Sean. Hey, everybody. So, if you haven't met me before, I'm Jason. I also go by BarrySploit. Call me Barry. That's fine too. I've been doing this cyber thing for about 8 years now. Primarily come from an incident response and purple teaming background. Um, as I go through this, please feel free to stop me anytime if you have questions. It is a lot of information. Um, One of the things that kind of brings this up is the CTF that we're putting on. I know I mentioned it a little bit earlier on the call, but if you go to ctf.null404.org, we are doing that DFIR, Digital Forensics Incident Response related CTF, where you can win that TCM voucher. So please go sign up, and yeah, hopefully you'll learn something from it. But back to tracking lateral movement. It's one of the hardest things that I think SOCs have to do in the modern day. I think the traditional approach to securing your environment has always been building a really secure wall, building that moat around your environment. But then how do you actually manage and track things once they're inside, right? Because there are going to be times where your AV, for example, doesn't pick things up. So if you're in the events where hopefully you're not, but if you are in the event where a ransomware incident happened, right, you want to know, all right, how did the threat actor move throughout the environment, figure out where that first host is, and remediate it, right? So going into this, just a little bit of overview about the different types things we're going to talk about. So we're going to talk about, what is lateral movement, why is it important, and then I have a bunch of the different types of techniques that we're going to be going through. So whether that's some method via SMB, RDP, WMI, WinRM, mapping shares, or there's other RPC related methods as well, such as services and scheduled tasks. So yeah, this is what we're going to be going through. So let's just start off with real basic. What is lateral movement, right? So this is unified kill chain. My personal opinion, I like this better than the Lockheed Martin kill chain because it shows a little better about what the attack cycle is. So once they're initially on in your environment, this is where a lot of our defenses currently play in. But once they're on there, right, they're going to be doing pivoting, more discovery of your environment, whether that's getting lists of domain users, etc. But eventually, once they pwn the one box, they're going to want to move to another box. Maybe there's more credentials and things that they can get off of that box. So this is where we're at specifically in this kill chain, is in this lateral movement section right before they go into collection, exfiltration, impact, the deploying the ransomware throughout the environment, right? This is really that cycle where they're going from just having a foothold to taking over your entire environment. So that's what we're going to be tracking here, is looking for that type of activity. I can tell you from a professional IR perspective, it is pretty difficult to track these because genuine threat actor activity does resemble regular admin activity in a lot of these logs. So having some automated tools to help do that kind of user behavioral analysis and understanding what's important, or making sure that you're tuning these SIM rules as we go through them, are pretty crucial to being able to understand this, right? Sometimes it's as simple as just asking, hey, admin, was this you? And, if they say no, you got an incident. If it was them and it's approved activity, you're good to go. So, I do want to start off because one thing that I see a lot of junior analysts getting or not quite understanding is the difference between the different types of authentication. So I'm going to primarily be talking about Windows Active Directory environments because that applies to the majority of us. But there's two different ways that you can authenticate. You can authenticate to that local host itself. So if you have a workstation, those are going to be like that local administrator account. Maybe some of your developers have local accounts on that machine. And then the other type of authentication is ones that have to go to the domain controller first in order to, because those credentials are stored centrally, not on the endpoint themselves. So a couple of different things here. if you're looking for those domain authentications, right? I'm trying to log in with an AD account. These are the types of logs that we're going to be looking at that are generated specifically on that domain controller. These local authentication events, for example, some of these log on and log offs, they'll be on the host, whether they're domain or local accounts, regardless. But these are going to find on the local host themselves, and these are the ones that you're going to find on the domain controllers. Fun fact you may not know, domain controllers actually don't have local accounts. The local administrator accounts for domain controllers are actually the domain admin accounts. So that's why they're so important. I do have a quick little screenshot if you're looking, for example, here's these 4776. So this is if somebody's trying to authenticate via NTLM, which is one of the two kind of authentication protocols that you'll see. It's either going to be NTLM or Kerberos. And this is one of those ones where it's important to look at the keyword here because you'll see audit success. That means it was success. They successfully logged in. You might see audit failure for these ones if it is a failure event. So any questions on this one? Cool. So getting into our lateral movement techniques now, the number one thing, and your admins probably do this, is using RDP, right? Remote desktop protocol. If you've never used it before, you've only ever had other methods for remotely administering your systems, right? Think about how admins have to manage, your thousands of devices, right? These are the type of mechanisms we're going to be talking about. RDP is pretty common, and attackers absolutely love to use it too. Partially because it's built into Windows. Super, super easy that way, right? When we're talking about detecting these things, there's a couple things to be aware of. So the number one thing is with this security event log, you'll find these 4624s. Remember, this is local, so you're going to find these on the actual like the workstation themselves. And in each of those, you're going to see there's a logon type field. If you see logon type 10, that means that it was initiated via RDP. So it's pretty easy to track that way. But considering that threat actor or admins use it pretty regularly too, yeah, it can be difficult. The other thing too is you may not actively be using RDP in your environment, but you absolutely should be monitoring it. For example, we're going to talk about PsExec later, and PsExec, yeah, you can run commands remotely, you can get interactive shells, but things I've seen time and time again are things like somebody using PsExec to just run a command like the ones you see down below, where it's going to open up RDP so the threat actor can log in. Part of the reason they do this is because instead of having to come up with some cool new UAC bypass, they can just RDP in, and when it prompts them saying, yes, no, do you want to allow this? They just click yes, right? No fancy exploits or anything required. And I do have some of the other event IDs listed here. Real quick, I do want to go. I have a couple screenshots in here. So this is the general authentication flow that your RDP sessions kind of go through. So here it shows you what the event, what the description is, what event log it's coming from, and then I guess what parts are happening there. So if we're successfully logging on, right, we're going to get this user authentication succeeded. This is a little misleading, so it's easier to use this 4624 instead. And then once it's actually started successfully, you're going to get these event ID 21 and 22s, basically meaning, yeah, the GUI, the desktop has showed up for whoever's accessing the system. And the reason that I say this 1149 is a little misleading. If we go to the next slide, here we're looking at the unsuccessful logon. You can see with the 1149, it still says user authentication succeeded. This just means that the network connection was successful, not necessarily that they actually authenticated to the system. And then you'll see the 4625 for the account failing to log on. So this is there'll be I think it's the error code on there. It'll either be the error code or a logon error or something like that. That specific error, you can look it up and it'll tell you, was it a bad username, bad password, etc. So also helps you in your investigations there. I do want to give a quick shout out to 13 Cubed for this. They have some really awesome cheat sheets, including some of the like a lot of the event logs that I'm referencing now. They got some great cheat sheets. I use those going into some of my GSE exams. So that's great. And also, if you want to see some of these in action, so you want to see them actually do these logins and then see the logs right afterwards, right, in the kind of a lab environment. 13Cube does have a YouTube channel. Bit too long to go through all the content, so let's sit here if you want to keep digging into any of these. Any questions on RDP? Cool. So next kind of protocol that's used pretty regularly is SMB. So this is, traditionally this is for whether you're mapping file shares, printers, and a lot of those different kind of IPC calls. And if you're not familiar with IPC, think of it as a way that applications from one host can communicate to another host, like through the application, right? So it's kind of this. This is where named pipes come into play. Just think of it as the connection between one app on one host to another host. They communicate using IPC over SMB. Ports that are involved here are going to be all those NetBIOS ports. So that's going to be 137 to 139, as well as 445 traditionally. When we talk about lateral movement using SMB, a couple things come to mind. We got PsExec, which is a standard kind of Microsoft tool, as well as SMB-exec, which is a kind of spin-off from PsExec that originally came from Impacket. Yeah, and there's a couple of different ones that you should be aware of. So when I talk about IPC, or I talk about named pipes, right? A couple built-in shares to every single host that you should absolutely know are listed here. So admin $, maps directly to C:\Windows. Simply put, this means that if I'm mapping a share, right? Typically in your share, you're going to have // computer name, /, and then the folder. In these cases, if I'm trying to access the C drive of that system, I'll put the host name /C $, and now I'm accessing the C drive of that remote system. Yeah, same thing with admin $. It goes to C:\Windows. IPC, this is always called whenever you're trying to authenticate to a remote system. And it's also where all of your named pipes come in. Yeah, any questions on SMB as a whole? I know it can be kind of complex, so I want to address anything real quick before I jump into some of the specifics. Okay. Yeah, no worries. If anything comes up, feel free to speak up. So we're going to start with PsExec. So as I mentioned, it's a legitimate tool published by Microsoft. That's part of the sysinternal suite. There are a couple implementations from other tools like Impacket or Empire, Metasploit. All of these have their own kind of version of PsExec, but they all kind of work a little bit similar. Threat actors really love to use the built-in sysinternals PsExec because it is signed by Microsoft. So you're not dropping any malware onto the systems. You're using built-in signed executables by Microsoft, right? Why would you not trust Microsoft? But it's being abused poorly, right? So kind of diving into how this works on a lower level. So first off, if you're looking at the sys internals, like the Microsoft version, this is the process it kind of goes down. So originally, it goes to C Windows on the remote, on the destination host. It drops this PsExec service on the remote system in this location, and then it creates a service over SMB. So remotely creates a service on that destination. The service name is going to be PsExec service. You can change it with some command line arguments, and then the path is going to be pointing to this executable that had originally dropped. Other point to notice is that it does create 3 named pipes for facilitating that kind of command execution. Because I see admins legitimately use this all the time. Like if you're trying to troubleshoot a remote host, you might run a command like you see down here below, where you run something as simple as this, and now you have a remote shell on another host in your environment. So can be used legitimately and maliciously. If you're looking at the Impacket version or the Metasploit version, something like that, it's pretty similar. However, the only things that are really changed by default, it uses a random 8-character service name, and instead of this being PsExec serve.exe, it's some other random 8-character exe that's dropped to this location instead. So that's really the only difference there. When we're talking about detection opportunities, I got a bunch of different event IDs dropped down over here, mostly related to the service creation because it does create that service. You can look for file creations for that psexec.exe or any other 8-character named executable there. You can also look for any access to one of these remote shares, right? So that admin $ remote share, you can monitor for that explicitly. If so for this 4648, it's this logon was used using explicit credentials. If the admin or adversary used something like we see down here below, where they specifically said domain, username, and a password, they're using something other than what their session currently is. So this is not me. This is a separate username password. Then it creates this event ID. And then if you have sysmon enabled in your environment, if you edit the configuration for your sysmon, it's a XML format. You can actually have it monitor for named pipes as well. And this is the named pipe that is used anytime you're creating a service remotely. So regardless of whether it's via SMB or not, this named pipe is created. And so a good way to tune this is if you're feeding this event log into your SIM, for example, if you're looking for any of these events, this activity should only be coming from your administrator workstations. If you have somebody from accounting who is creating services on remote computers, right, you should be raising alarm bells. So, but that is it for PsExec. Questions on that one? Cool. So another similar version, still sticking with the SMB theme, is SMB exec. You think it's pretty similar to PsExec, but it works just a little slightly differently. So going back to my PsExec slides real quick, the way that standard input output of this interactive shell is handled with PsExec is through these named pipes. So it's PsExec, hostname, some random value, and then standard in, standard out, or standard error. When we're using SMB exec, it's a little bit different. So instead of using those named pipes, it's going to use this file called __ output instead. So it goes through pretty much the same process, creates a service over SMB. It's going to have random 8 characters, lower and uppercase. It can be editable. Like if you go into Metasploit and change it, can do that. So that alone is not the best way to detect it. However, the service path or the binary path that service uses is going to look something similar to this. So basically, to break this down super simply, this top line is going to be whatever command the attacker is running. So in this case, if you're doing an interactive shell via SMB exec, the first command that's going to get ran is CD. That's why I have this here as the example. So you can see it's echoing CD. It's going to put that into, this is actually on the local host C drive in __ output. And then, yeah, basically it's going to take any other commands that are in this bat file if you're running commands afterwards. And then what it does is it runs all those commands, puts the output into this output file, and then deletes the bat file afterwards. So you'll see a bunch of services getting created that kind of do this. So yeah, it's a pretty good indicator. Otherwise, another good sim rule to have for this is looking for that C root of your drive _ output, because all the outputs from the commands are going to be put there and then subsequently deleted. So if you're working in incident response and you're trying to see, when was the first time that the attacker did this, you either look for the first time this service was created, or you look for the first time in like the master file table, for example, that this _ output file was created. And now first time the attacker started running commands. Yeah. So kind of touched on the detection opportunities a little bit. Same sort of deal. You can look for those bat files being written and deleted in the short times. You can look for the 8 character. So the name of the bat file is 8 characters. As far as I'm aware, that's not editable. So that's a pretty good detection mechanism. And then the other ones are if you're looking for services that start with CMD/C, or you're looking for those __ output files. Those are also pretty good. And then just like I mentioned before, a couple different ways to track those named pipes that are getting created. You can either see that service CTL through your sysmon, or there's this other event ID that you'll see in security. That's a 5145. You'll actually see those named pipes being accessed here as well. So any questions on SMB exec? I probably don't see this one much in the wild as a regular PsExec because I think most people are or should be detecting those bat files being written and deleted in short amounts of time. So perfect. So I got a couple examples here because I know that was a lot of information kind of just got thrown at you. So here is the example of a log being created. So this is a service being created. The service name here is this random 8 character string. And then you can see that the service file name is just like we saw before, right? So ComSpec is a shortcut for CMD, and it's echoing command prompt, and it's actually going to be doing the same exact thing that we saw above, right? So it's going to be outputting things to output, running whatever in the bat file, and then subsequently deleting it. So any yeah, pretty good on there. There's one more on here. This is that 5145 event ID that I mentioned. You may or may not have this enabled in your environment. It does get pretty noisy because it's every time somebody has accessed something over a share, it's going to show you what the share was and then exactly what was connected to on that share. So in this case, we can see the local share IPC $ was accessed, and what was accessed on that share SVC CTL. So we know in this case the source address, this IP address here, actually created a service. As we can see, here's this name piped here. Any questions on this? Does that make sense? All right. I'm going to take nothing is something. All right, so that's enough for SMB and RDP for now. Another method that commonly gets used is WMI, and this is not always WMI is not always used for lateral movement as well. It's super common throughout a lot of your environments, right? It's basically I think of it as a window as an API for Windows components, right? It's got a almost a database of everything, so you can query WMI to get a list of all your processes, all your services, your BIOS settings, the hardware, your CPU utilization, right? Like everything about your computer is stored in WMI in some way, shape, or form. But considering that it's stored there, we can also interact with it. So pretty much anything that can interact with the Windows API can interact with WMI. So that includes things like the wmic.exe. It's a pretty good one. PowerShell can query it via VB-script can query it. And here's an example command with PowerShell where we're just listing off every process and we're actually getting the parent process IDs as well. When it comes to detecting this information, it can be a little difficult to get any specifics. So, like, for example, this query may not be logged within any WMI related logs. You might find it in PowerShell related logs, but the querying of WMI itself is so noisy that it's usually not enabled. So how do we detect these things? Anytime a process is created via WMI, the parent process is always going to be this WMI.prvse. So that's a pretty good indicator that something was spawned via WMI. The hardest part is usually figuring out what spawned that process. But if you're building detections in your SIM, for example, anything that's using this, see what in your environment is regularly being spawned by WMI, and anything outside of that, make sure you're alerting on it, right? Especially if it's something like WMI is spawning PowerShell or some unknown like CMD or some unknown executable, definitely want to make sure you're alerting on those. Other thing with this is if we are using WMI to uh, move laterally, um, the initial connection from the source to the destination goes to that destination port 135. So if you see that initial connection here, followed by this process, pretty good indicator that this was spawned remotely. Um, there are a couple WMI related logs that are good. So there is this Microsoft Windows WMI activity operational. That's where you may see things like these queries, depending on the on the kind of level of logging that's set. It is not enabled by default. So if you do want to enable it, I did add a command here down at the bottom where you can enable this specific log. And here's a couple of different event IDs that you'll get, whether they're people using WMI for persistence or running queries. Yeah, you'll see all that information in these logs if it's enabled. Other thing, if they're using PowerShell to do all this, make sure you go check that PowerShell script block logging. Those are those 4104 events inside of that PowerShell operational log. Here's an example of how we can kind of track that WMI lateral movement. As you can tell, none of these things are really straightforward, right? It really does take some correlation of multiple events together to really make sure, oh yeah, this is definitely what occurred. So here's our example process tree on our destination host. You can see our parent process is at WMI PRVSE. And it's actually running PowerShell that's running no profile, running a command, and that command is going to be reaching out to this domain and then piping that into IEX, which is invoke expression. So it's going to reach out to whatever on that domain. There should be a wget there. That's my fault. So it would be wget that domain and then piping it into IEX, and it's going to execute it. So how do we detect these things? Biggest thing is that 4624. Remember, that's that logon event ID. Logon type 3 is anything that's going to be network based. So if you look over here on the right, you can see here's this 4624 event. And you can see logon type 3. That means it's some type of network based authentication. It's not logon type 10, so we know it's not RDP, for example. We can see what user was authenticating, and we can see where it was authenticating from. This doesn't necessarily just mean that it was WMI. However, if we kind of combine the timelines together, these logs aren't a good example because I got these from two separate hosts. But if you combine them, if you kind of look at them together, here in this case, you can see this is Sysmon event 3. This is a network connection event. You can also look at any other network-based logs that you have, where the destination port in this case is going to be that 135. So it's reaching out over an RPC port, and then spawning that WMI process, as well as correlating this there. So kind of those three events together, the process create for WMI PRVSE, the network-based log on here, and the network connection going to that port. All three of those can kind of indicate, yeah, this is exactly what's going on. Any questions on that?
Hey Barry, you hear me okay?
Yep.
Oh, yeah, sorry, I was trying to chat earlier. My mic was messed up. You mentioned earlier with the previous SMB exec. Is that you're saying you said that that is from how are users getting that installed?
So
Just
SMB exec is originally from Impacket, so it's a Python script. But it doesn't necessarily, like in this case, or even with PsExec, for example, it does not necessarily have to be on one of your endpoints in your environment, right? A lot of times, what we'll see is it kind of go through a pivot point, uh, like whatever that beachhead kind of host is. So um, it so whatever host we originally have, we kind of use it. The attackers will use it as a proxy. So you may not actually see process creation events for psexec.exe on the source device. You might not have access to it. But on the endpoint, you'll see this information there. So the attacker is running it from a Python script or from their C2 framework. And all you'll see on your endpoint is the service getting created and the service path kind of getting spun up there. Does that make
on the
sense?
network. Yeah, on the networking side, is there any signatures you could use to catch that outside of just processes being launched?
Not specifically network based. You really do need to look at, like these named pipes and things on the endpoint, because it uses regular network like protocols, right? Like you're going to see SMB in your corporate environment at scale all the time, right? People accessing shares, things of that nature, admins doing their jobs, uh, mapping printers, right? All of that information is going over SMB. So yeah, and same thing with the WMI one. It's using RPC, which is usually, that's it's just how computers communicate together over networks. So it's really hard to even pinpoint what applications are communicating over that one for WMI, for example.
Got it. Yeah, that makes sense. Yeah, I didn't know if there's any other way to catch that, but yeah, since it's the normal protocol, I guess just makes it that much harder.
Yeah, yeah, and yeah, that's why I mentioned earlier the big best things you can do is correlate that information together and make sure that it's if you're looking at the network traffic or looking at source and destinations right for when an event like this occurs, make sure that it's just coming from those approved administrator connections. Or if you have a solution that can enforce MFA on these types of high risk activities, that absolutely recommend. So
Cool. Thanks.
yeah, no problem. Perfect. So lastly, I did want to mention a little bit just touching on mapping network shares. Mapping network shares itself is not necessarily a way to laterally move. However, it kind of can. It plays a part, but mapping shares itself is not just laterally moving. A couple of ways that we see this typically done is either if an attacker has access to a share drive, they may put their malware, their C2 beacon, their payload, whatever, on the share drive, and then try to do some internal phishing to have some other users, somebody from the help desk, try to run it, for example. Or just like we saw with all the SMB related things, they really are mapping $, or IPC $, right? That's what all those named pipes really are. So all of those are technically considered network shares. The other things that you may see is attackers mapping that $. So mapping the root or that mapping the file system of a separate host. They do need admin credentials to do this. But for example, if in my environment I have a unmanaged host, right? I have somebody broke into my building and they plugged in a device and now they're on there and maybe they brute force got some admin credentials, right? They may be able to, or they would be able to map the $, drive from any other host in the network that they have admin rights to. And they can drop whatever files they want in like the startup folder, for example, and just wait for the computer to restart and then run it. Right? They never did anything other than just drop that one file over SMB, right? By mapping it like a network share. So they made it. If they don't do something like that, they will need to still execute the files if they do drop them on the $, for example. But I do have an example in here for Akira ransomware. Common thing that they'll do. You may see a firewall get compromised, right? Maybe you got a Fortinet, right? Get hit with new Fortinet 0-day. They may use that as kind of their initial host. And then the Akira ransomware executable itself actually has a built-in mechanism to map the $, share on any remote host, and then just encrypt all those files on that kind of shared drive like that. So there's no malware on your devices. All that happens is they map that $, share, and then all your files start getting randomly encrypted. Bam, 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 bam. And hopefully whatever EDR you have kind of catches it in time before this happens. But that's just a kind of simple example about how one device on your network, right, being unmanaged can lead to full domain-wide ransomware without them even logging in to another host, for example. So that's why I mentioned mapping those network shares is super important, and making sure that it's just coming from those approved admin workstations. If your firewall is mapping $, right, that's a problem. So something I definitely don't see managed enough. There's really not a whole ton of logs there. You'll see these common authentication event IDs that you see previously. And then the ones that you really want to look for are those 5140s. That's just a generic, like they mapped $. And then 5145s, that's they mapped $, and accessed these specific files. So that one can be noisy, but if you have it, it's a gold mine. Any questions on that one?
I guess just generally, have you found that depending on the scene that you're using, these kinds of detections are already like built in, or do they have to be built?
I guess it really depends on your product, right? I think the only ones that I really know that come with rules by default is like Elastic. I think Elastic comes with rules by default now. Um, but it's just some things that you want to make sure are in there. And even if it has the rules, right? If you don't have the logs that are feeding in there to trigger the rules, right? That's a whole nother problem. So I'm a firm believer in do it and see if you trigger some detections, right? That's the best way to test it. So
Very cool. Thank you.
yeah. All right, so moving on, WinRM. This one is by far my favorite one as an admin. I know not a whole lot of people have used this in the past, but basically this is Windows remote management. So another term for it is PowerShell remoting uses this protocol. So it uses these ports here, 5985 and 5986 if you want to do TLS. Fun fact, it's actually encrypted by default. Even if you're using, the non-TLS version, it's encrypted via Kerberos tickets. So not too bad there. The parent process that you'll see for all of these are going to be that WSM prov host. So similar like how we saw with WMI, where it always spawns this process. This is a separate one to put it on your cheat sheet. This one is for WinRM. Yeah, if you see this one, it's PowerShell remoting. Just like how we saw with, or how I mentioned with RDP, attackers will use something like PsExec to run some commands just to enable RDP. I've seen attackers do the same thing with this, where they will, use PsExec, run something like enable PS remoting on the remote server, and now they just get, run enter PS session, and now they have an interactive shell like we see up here at the top. So this was me just, doing enter PS session to Winterfell, and now here I am. I have an interactive PowerShell prompt on that. So super simple from an attacker's perspective. Run PsExec to run this one PowerShell command, and now you have an interactive shell. Luckily, with PowerShell, there's really good logging. Microsoft's done a great job over the years of really improving that, and so I have a lot of the good kind of logging ones here. Big ones are the session creates, as well as the user auth, just in case they're trying to authenticate with different users and they're failing. And then script block logging. This is really where you're going to get the majority of the information about what the attackers ran in that interactive shell. You're going to get all that information there. Other cool thing with the WinRM is you can do invoke command. Instead of getting an interactive session, just like with PsExec, you can do invoke command and just run one simple command. I know when I was an admin, I use this all the time. Basically, you can run it across a bunch of hosts. You can put an array of computer names here and run one command across all those hosts asynchronously. So pretty nice there. Any questions on WinRM? Cool. And then the last thing I want to touch on is all the extra RPC related events. So I know I mentioned those name pipes and those kind of remote connections like that. There are some built-in ones. If you didn't know, if you are an admin and you've used SC, for example, right, to query scheduled tasks or to query services, sorry, you can actually there's an option in there to do it on a remote computer, on a target computer. So attackers might do the same thing, use something like SC, scheduled tasks, AT, and actually create scheduled tasks or services on remote systems just by using these built-in commands. Um, so same sort of detection mechanisms. Make sure they're coming from those approved admin workstations. Making sure you're tracking how normal is this in your environment. And like River had asked, if you do have sim rules for these, it usually does take some tuning to get these things to be effective. But I do have some event IDs listed off here. So if you go look in system, right, these are event IDs for new scheduled tasks. Here's the security one for scheduled tasks. Same thing with services. And then an interesting one that you may or may not have done in the past is a remote registry. Typically, this is related to a service called remote registry. If your environment doesn't do it, so for example, the way this is used legitimately, you can actually pull up regedit and connect to a remote computer. You can use the reg command and connect to a remote computer. So same type of idea there. So you'll want to look for those service starts for the remote registry. And then if you have those 5145s enabled, you can look for those specific named pipes going to the registry. I didn't put the name in there. I'll have to update this. Yeah, and the biggest weakness of these. So, for example, with services, if you look at the 7045 event, yeah, you'll see there's a new service that was created. You'll get all the information about the service, what it was going to run, etc. However, you're not going to see who created that service. All your services are going to run as system by default. So you do have to, when these are created, kind of correlate those with those network events like we previously saw, or those logon type 3 events as well, and figure out where was this created, right? So it's kind of the challenges with these. Any questions on this one? This is the end of my slide, so I'm gonna switch over to a different screen real quick, and I'll show you how PsExec works, and then I'll show you how to parse the event logs using some Eric Zimmerman tools, which make it pretty easy. So, but yeah, lastly, any questions on this as I switch everything around?
I have a question.
Yeah.
It was on SMB, the last slide, where I think you had a share, and somehow it created a service, I think is what you said. I'm just confused on how the two connects.
Are you mentioning this one?
Nope, still back. It was like the last slide for SMB at this one.
Gotcha. So, funny enough, all those named pipes are actually connecting to this IPC $ share. So, I know on one of these previous slides, you can see here's the name pipe where it's looking at pipe SVC CTL, right? That's how it shows up in Sysmon, or probably a lot of your like EDR tooling, for example. However, technically, this is it actually just mapping to the IPC $ share with this specific name pipe. Does that make sense?
I see. So IPC $ always exists, and you can map different types of things to it based on what you want to do.
Correct. So in this case, this is the kind of I guess this is the named this is the pipe, or anything going to this is going to be creating Windows services. IPC $ is also used for things outside of this as well. So like if if I'm trying to authenticate to this device, I actually authenticate by pointing all my authentication data to IPC $. So it's used for a lot of things. However, all your named pipes are also associated with this.
I see. And can a user create new named pipes?
I believe it has to be admin. You need admin rights to do it.
Gotcha. Okay. So this is something that already exists that you can leverage. You don't have to create a new one.
Correct. Yeah.
Okay. Gotcha. Thank you.
Yeah, no problem. Yeah, and I think and somebody correct me if I'm wrong here, but I believe like even the if you're familiar with Metasploit, right, you have a Meterpreter shell, or a lot of other C2s have it nowadays. If you do like the get system command, if you have admin rights, it actually just creates a named pipe that runs your like all your data through, and that's how you get system level access. So
I see.
perfect. I'm gonna swap over here. So this is just my range environment. Can you guys see my PowerShell terminal here?
Yeah.
Yep.
So I already downloaded this, but you can see I downloaded the PS internals suite. So it's got a lot of tools in here. However, one of them is PsExec. So if we take a look at the options for PsExec, I know we mentioned kind of the default service names and things of that sort. The thing is a lot of that stuff can also be edited. So the general usage is going to be PsExec pointed at the targets that you want. You can specify a username and password. You can give it a service name if you want, and then at the end you're going to run whatever command with arguments that you want. But as you can see, the service name is editable. So service name itself is not always the most useful detection mechanism. Other option, you can run it either as the user whose credentials you specify, or you can run it as the system account on that remote server, the remote host as well. So what we're going to do, I actually already have it prepped up here. But I have basically, I'm going to be using this command. We're going to run PsExec. I'm going to point it at my Winterfell server. I'm going to give it this username and give it this password of password. No, super secure, right? And then all I'm going to be doing in this case is getting an interactive command prompt. So if I wanted to, right, I could do CMD, or I could do like who am I, and it would just run this. Like we can even run it here. And here we get the results back. So that's us just running one command. Or we can just get one single interactive shell. Right now, if I do like host name, we can see I'm actually logged into Winterfell. Yeah, so I'll commonly see attackers will either do something like this where they get an interactive shell, or if they want to use something like RDP, ideally, they'll just put a command here, like the reg command, that opens up, runs that command that we saw on the slide that will open up RDP. Then they can RDP in and do whatever they want. So, yeah, pretty powerful tool if they have those credentials. But yeah, we can take, sorry, LS, even though it was thought it was PowerShell, but it's CMD. But that is that. We can even see I'm logged into Winterfell up on the top. Let me change from sharing one more time, and I'll walk you through analyzing these event logs. I did drop them in the chat. You see there's that security event log, as well as the sysmon log that is there. So I'm going to swap this to just sharing my whole screen. And then I'm going to pull up a PowerShell terminal. All right. If you're not familiar, or if you're going to do the CTF and you're not familiar, one thing that you definitely want to get used to if you want to work in digital forensics is these Eric Zimmerman tools. So I'll drop a link in the chat, but he has a bunch of different tools for parsing different Windows forensic artifacts. So whether you're trying to parse the master file table, or you simply are looking at event logs and want it to, make it in an easy digestible format, there might be, I think we talked about at least 6 different event logs, right? It would be much easier if we could just put all that into one Excel sheet, one CSV, right? So that's what we're going to be doing here. So in that case, I'm going to be using this EVTX ECMD. So I'm going to go ahead and change in that directory. And I have the EVTX ECMD in here. I'm going to remove all my old CSVs real quick. Perfect. All right. So, yeah, here we are. Now, the basic syntax for how we want to do this is always going to be something similar to what we see here. So it's going to be evtx-ecmd. We can point it at a single file like this. And then if we want to get a CSV, we just tell it where we want to drop it out. And then we can also alternatively do a -d and point it at an entire directory. So it'll process everything that's in there. So let me make sure all my event logs are in one folder real quick. Perfect. So I'm going to point it at the directory where I have both of those logs, which is going to be on my desktop inside of null. And then both of my things are in there. So by ls that, for example, just double check. All right, I have both of those logs in there. So we'll do -d, and we want to drop it to a CSV, and I'm just going to put it in the current directory. So I'm just going to put a dot. Remember, 2 dots is 1 directory up, single dot is current directory. I'm going to go ahead and run that. It's going to run parse both of those event logs, and then it's going to put it into this CSV in this current directory. Eric Zimmerman does have another tool that I like to use called Timeline Explorer. Pretty easy way to see CSV if you don't have, Office 365 license for Excel. You can also use like LibreOffice, for example. But I like Timeline Explorer, so that's what I'm going to be using when this finishes. It's actually taking a lot longer than I expected. It's usually pretty quick. While this runs, any other questions?
Yeah, the event files that you're parsing currently, they're the Windows format that you see in like the event viewer.
Yes. Yeah, that's that .evtx files.
And how does parsing them help?
Yeah, so instead of, where I have it like this, where, I can click into this and view the one log at a time. Also, it's a little bit ugly to use event viewer. You might be, okay with it. But the easier way, in my opinion, is to take all those logs and then put them into something that's easily searchable, like a CSV, for example.
Yeah, no, I agree with the view. It's not the best. I'm just wondering, like, does it add extra things? Does it correlate other stuff, or is it literally just converting the XML into like a more readable, organized structure?
It doesn't add anything extra. It's just putting it into a CSV.
It's more easily searchable. So if you think of like an Excel spreadsheet or a workbook, you can kind of create like the same thing as like a pivot table. So you're just looking at certain parts of the log instead of looking at the entire log and sifting through all the information. Like if you kind of have an idea of what you're looking for, you can search and just see if it pops up in there in all the event logs.
Gotcha.
Yeah, I really like. I know you can do this in Excel nowadays too, but I really like this Timeline Explorer because it makes it pretty easy. So, for example, if you've never used this in the past, you can do a broad text search across everything, and then you can also do filters based off of certain columns. So, if I want to do event IDs, and let's just look for 5145s, put that here, filters for it. The other thing we can do with this is if you hover over, there's this tiny little filter button right here. And it shows you all the different values that are acceptable. So you can, click and just say, I want this one, and I want this one, and I want this one maybe too. Which one's, I got to look up the named pipe one, sorry. 17 and 18. Get rid of the process creates. Noisy. Yeah, so you can do that, and then you can also apply to a bunch of other ones as well. So that's why this is my go-to tool. Yeah, so, but yeah, there's nothing really extra in here. You can see it's pretty basic when it comes to the payload, titles. And then the raw payload is here at the very end if you still need it. So
Which is cool. Yeah, I see what you mean by making it easier to search, though. Yeah.
Yeah, definitely, right. And then, like, if, for example, if we just want ones that have remote hosts, right? We could do this, and then or do could even like search in here. It's 10 dot something, right? I'm not gonna do that. So yeah, we'll start with this. So we know we ran PsExec, right? Based off of the slide, we have a couple different things that we could see, right? There was the service that got created. We could check for that file being dropped. In this case, I don't have any logs for file create events, so we won't see that that file show up. But we'll have those 3 named pipes. I'll even pull it up here. So we have the service name. We have those 3 named pipes, so we can go take a look for any of those, right? So let's do that. Let's go. Just looking at named pipes. We'll just do 1718s. So those are our named pipes. And then let's see. Pipes created, pipes connected. And here's those pipe names. So we can see, yeah, I actually ran this twice because I ran it earlier as well. You can see standard in, standard out, standard error, standard in, standard out, standard error, right? So we can see those named pipes. Pretty simple for that one. Get rid of our filter. And then let's go take a look for those service create events. I didn't pull 7045s are in the security log. So this one's 4697. All right. Did I get that mask backwards? I'm not seeing it in here.
Was it 4796? Pretty sure we did
4768?
that.
Nope, not that one. Let's just look at the description. The shares, scheduled task updated, named pipe, service configuration change, maybe. I'll have to go in and see why my auditing did not pick this up. Yeah, no, this was me updating my sysmon config. Yeah, I'll have to see why that didn't I didn't pick that up. Interesting. And this is why we test things. Okay, perfect. Well, that's pretty much all that I had. Yeah, so you only other things that you would see on here are that PsExec service .exe being dropped in C Windows, as well as that service name for PsExec serve being created. I guess one other thing we could also check if we look at the named pipes. Oh, I didn't set that. Okay. The other one that we should see is that SVC CTL, but I don't think my config for that has. I don't think that's set in here. You see, this is my sysmon config that I'm using. These are all the pipe names that I'm looking at. So I bet you if I updated this to also look for SVC CTL, I bet you I would get that. I'm not seeing that in here. Oh, there it is. Why did it not show up then? Maybe it doesn't have the backslash. I'll have to test it. But anyways, that is my talk. Thank you guys. I hope you learned something. So, and I hope that you learned something that you can take back to your SOC if you work in one, and create some great detection rules to help stop those adversaries.
Great talk. Loved it.
Thank you.
Yeah, thanks, Barry. Great talk again. Yeah, that was really thorough. So I'm glad we recorded it.
Yeah, appreciate it. Yeah, I took definitely I had a couple of my other IR buddies take a look at this too to make sure got pretty much everything in here. So hopefully